Then this is the way each of the problems explained along with the special case problem. And I'm assuming that you all have understood the solutions of each of the problems. And if you don't have any question, then I'm thinking that the last question will be enough for you to get, and that will be enough. This is the one, what I'm talking about, the last question, which is a special case problem. You can see here, presence of zero row. After going through this is the last problem of the video lecture, that what I have sent you by email. Zero row, then you have to understand that there are what? There are closed loop pole located on the imaginary axis. Remember, this is the very important thing what I wanted to tell you. So in the question, what you have to find, in fact, is you have to find that how many poles, closed loop poles, are located on the imaginary axis or real the left half of the S-plane or right half of the S-plane or on the imaginary axis. That is the thing you have to go for. Now, if you want to do that, then you have to identify there are poles located on the imaginary axis. Why? Because zero row present. This is the main reason. Fine. When zero row comes, then how to find out that the system is either stable or unstable? That means in the first column, you have to find positive, negative, and if there is any sign changes system. So if you don't know what is the value here instead of zero, you cannot do that. But if the full zero row comes, then you have to apply what that one already in the video lecture you saw. But still, I'm going to tell you, you have to take the auxiliary equation just above the zero row. This is the auxiliary equation above the zero row you have to consider here. Now, if you do that, then how you can do the auxiliary equation? This is the zero row. Above the zero row, this is the auxiliary equation, the 2x to the power 4 and 48 s square and minus 50 equal to 0. This is the auxiliary equation. Just above the zero row, you have to build up. Then you have to take, you have seen the video, I think you understand. Then you have to take the first derivative. If you take the first derivative, you get DDS, and then you're getting this gut. Then it is coming s cube and s to the 1. So s cube 8 is coming here instead of 0, and s to the power 1 coefficient 96, because s cube coefficient, here is s cube coefficient should be 8, and s to the s to the 1 coefficient will be the next one, which is 96. That's all 0. Don't worry about it. On the right hand side, 0. Now, this 0 replaced by the 8 and 96, how you got it? From the auxiliary equation, you take the derivative and then you get it. So you understand. And then the next row, you have to calculate just above the 2 row, this one and this one. From this 2 row, you have to calculate the row. And how you already know that. You have seen the video lecture, and then you saw that how to do the calculation, and the calculation according to the Ruthian law. Actually, you have to 8 times 48 minus 96 times 2 divided by 8 is 24. Again, this one is just minus 50, 0 divided by 8 is minus 50. So that minus 50 straight away come here. So these are the things coming here. And from there, next row, you can calculate in the same way. That is this into this divided by this, 8 into minus 50 divided by 24. You are getting this 112.67. And then minus 50 straight away coming here, because this into this minus 0 minus 24, 0 into 24 divided by this is giving you ultimately minus 50. Normally this number comes here. Now from here, you can easily you understood from the video lecture that one time sign changes, because last one is minus 1. So plus to 1, 1 time sign changes means it is clear that there is one closed loop pole located on the right half plane. So the system is unstable. Yeah. But the question is, my question, how many pole are on the right half, how many on the left half, and how many on the right half? You are clear here, one pole on the right half. But how many on the left half? That one will be coming. First question is, altogether how many poles are there? how many closed loop poles are there altogether? Can any one of you tell me here from the video lecture? You know that. What?
Sir, 6, I guess.
You kill yourself. What is this written?
Sir, 5, sir.
5. So if you factorize it, how many factor you should get here? 5 factor, right?
Yes, sir.
So 5 factor means 5 poles you should get. So you cannot say 6, I think. Okay, 5 factor. If you, okay, just a minute. I just know why it is not working. Oh. Oh no, sorry, I have to go for it. Okay. Hello, can you follow me?
Yes, sir.
Okay, so 5 factors, that's what 5 poles, 5 closed loop pole. Out of 5 closed loop pole, then you are having 1 on the right half plane, and how many left? 5 minus 1, another 4. Out of the 4, right? Out of the 4, how many of them are on the left half and how many on the imaginary axis? That is the question. That one, I think you saw the video and it was not shown in the video. Okay. Now listen, I'm just going to show you here. Hey, can you understand what I'm talking?
Yes, sir.
Okay. I'm talking about, okay, just have to take a screenshot here.
Sir, I have one question.
Yeah, go ahead, please.
Sir, just when we count the positive and negative changes values, so we also calculate the s to the power 0. I mean, the minus 50 is the minus 4, right? I mean, we took this for change of the minus, right? So there will be total 6 4. I mean, that's my question, sir.
Oh, here you go. Just a minute. I'm going to. I'm sorry. Can you repeat the question? What is that?
আমরা যখন ক্যালকুলেট করি তখন তো স্যার হচ্ছে টোটাল সবগুলাতেই ক্যালকুলেট করি মানে s টু দি পাওয়ার 0 থেকে s টু দি পাওয়ার 5 পর্যন্ত তো টোটাল তো 6টা পোল ক্যালকুলেট করি না স্যার মানে
Oh no. You are making trouble. You did not see the video lecture, I think. Have you?
Yes, sir, I did.
Then in the video lecture, it's clearly mentioned there. The general equation said what? S to the power on the top is s to the power m, and on the bottom is s to the power n. N is the number of pole, m is the number of zero, right?
Yeah, sir, I saw
So
that.
how many pole issues and characteristic equation Q is the which one? Top one or lower one? Bottom one?
Top one, sir.
Oh, that's why you are making trouble. I'm talking about C by R.
Yes, sir.
You are absolutely no idea. Bm s to the power m here, right? Let's say b0 s to the power m, and this is a0 s to the power n written there, right? Plus dot dot dot. The equation I'm talking about. Dot dot dot. Right? Can you remember this s to the power m and s to the power m? Here, s to the power n is the pole or 0, and m is what? Number of 0 or pole.
So s to the power n is the pole, sir.
Then the upper one is pole or 0?
Sir, 0.
Then why you say upper one is
Sorry,
pole?
sir,
That's my question. Absolutely, whatever. Okay, now listen. I'm just talking about this is coming from Q is coming from the lower part. This part, the pole, this is QS actually. Okay. Clear?
Yes, sir.
This is the characteristic equation, and this is the number of closed loop pole n. So here, number of closed loop pole n is what? 5, right?
Yeah, yes, sir.
If you factorize this polynomial, how many factor you get? This is what I show you in the servo system. There are 2 closed loop pole in the servo system we got, right? S square, second order system. This is 5th order system. That's why. Now we clear. Come on. Are you okay?
Yeah, sir. Yeah, sir.
So how many factors?
Sir,
still you're dark or what? How many
No,
factors here?
Sir, 5 factors.
5 factors. That's right. So 5 factors if you get, that means there are 5 closed loop pole. 1, 2, 3, 4, 5, right?
Yes, sir.
Okay, how many times Sanchez? Forget about your this s to the power 0 and s to the power 5. These are not number of pole. Okay.
Okay, sir.
Number of pole is this s to the power 5. How many pole? But this is the Ruthian array. It is his array he had constructed in this way. Why? Because s to the power 5, s to the dum, s to the power 1 here, and s, hey, 50 is s to the power 0, and that's why. It doesn't, yes, if it is s to the power just like that, will you say there are 6 pole here?
No, sir. That was not
Try to understand. Go back to Kindi. Listen what I'm talking. Don't waste time. And I'm sick, you guys make trouble so that I cannot take the class, then you go back home again, right? Look, this is plus, this is plus, this is plus, this is minus. How many times changes? One time here, right?
One time,
One time
yes.
changes. That's why one close on the right hand plane. Now the question is what? That is the first thing. Question is what? Look, I'm writing here. Can you see? Can you see what I'm writing here?
Yes, sir.
What I written? Can you tell me? Because it's
Fine.
outside the screen.
Fine,
Good.
sir.
Right. In the thing, what you have to, the question, right hand side, how many poles, close the poles on the right hand side, right? How many close the pole left hand side located? And how many poles on the imaginary axis or j omega axis? How many poles? So among how many altogether? Hey, how many altogether?
Sir,
I'm,
5, sir.
who is talking to me?
Sir, Nabil Haq, sir.
Sorry,
Nabil, sir.
Nadim.
Sir,
I
Nabil,
don't. Okay, Nabil, I don't understand. Rest of the 13 students, you have the same responsibility. You can answer also to make it easy. Okay, if there are 5 altogether, my question here, we found one time sign changes mean one pole on the right half plane. So answer here is 1. Right hand side, there is 1 pole. First, gone. Now out of 5, 1 is on the right half. Then how many left?
4.
That's right. Good. This is the
4.
way I want the answer. Okay. Altogether 4. Now, out of 4, how many on the left half and how many on the imaginary axis? For sure, there is some, for sure, there is some, for sure, there is some poles on the imaginary axis because this is a 0 row present in the Ruthian array. Ruthian array 0 row present means you have to understand there are closed loop pole located on the imaginary axis. Please stop. Now, question is how many on the imaginary axis, on the geometric axis, and how many on the left? Out of what? Out of 4, because 1 is already on the right hand. The out of 4, how many on the imaginary, how many on the left half? That's the question now. That will come from here. That is the question. Where it comes from the auxiliary equation. How many in the imaginary axis will come from the auxiliary equation. So auxiliary equation is what? Look at this auxiliary equation. I'm going to take the color as a blue color so that it will be easier. Now auxiliary equation, everybody, I think I'm writing it here. Hey, can you see on the right hand side? No, I think it's better here. Auxiliary equation is coming here. If I write it like this, s to the power 4 plus 24s square plus minus 25 equal to 0. Is it okay or not? Do you get it?
Yes, sir.
Auxiliary equation, at least you understood how to write the auxiliary equation because of 2s square 40 and video lecture told you. So if it is the auxiliary equation, we can, after dividing 2 both sides, then after dividing 2, you can get it. Now, s to the 4, so you go for s square. If you assume x, then it will be what in that case? It will be x square plus 24x minus 25 equal to 0. Right. Now, can anybody tell me what is the value of x? Quadratic equation solution. You have a calculator. Do it. 2 value you should get quadratic solution. Anyone? All of you, take your calculator and tell me. Don't leave the classroom. I'll give you the attendance at the end of the class. Any one of your friend absent from today's class will not get the attendance, and it is highly instructed by the administration. If your attendance is less than 70%, you cannot attend the midterm. So I'll just report it online. Ask your friend, those who
Hello,
are
sir.
not coming. Yeah, go ahead. What is the answer?
Sir, it is 1 and minus 25.
Okay, everybody agree?
Yes, sir.
Yes,
Yes,
sir.
sir.
Then why didn't you tell me? Okay, now uh, x is equal to 1, if x equal to 1, if you consider, that means s square equal to 1. That means s equal to plus minus 1, right? And another one is x equal to minus 5, minus 25. So that means what? S square equal to minus 25. Hey, s equal to what? Then if s square is minus 25, s equal to what? Anybody? Or back to Kindi? Huh? What? Jorek, loudly, duck like a dead gut.
5i.
Root 25 is what? 5. And there is a minus sign. So root over minus 1 is what?
Sir, I.
I means here we call it what? Hey, what is this duck? Over here. What is
Sir,
this?
imaginary
J.
axis.
J, right. Imaginary
J.
is what? I or J?
Sir,
In
J,
our
J.
case.
J.
J, sir, J.
Sir, J.
So this is a problem with you all. Okay, I'm just going to do it again because of I need a okay. J and root over 25 means I can write 5 as a J5. But before that, we can write G as S square. So plus minus. Can I write it like this? You say, sir, we cannot understand here what I write. Is it you don't get it what I have written here? Are you all okay? Okay. Problem that. Okay, look, this is S square is minus 25. And this is plus minus J5. Are you all dead or still alive? Can you respond? Is okay or not?
Yes, sir.
Yes, sir,
Got it.
it's okay.
Yes, sir.
So
Okay.
Yes, sir, it's okay.
these two poles are located where? Common sense?
In the,
Imaginary
in
axis.
the imaginary.
On the imaginary axis, right? One is in plus, another is a minus, Dambush. This is a plus J omega J5, and this is minus J5. These two are located on the imaginary axis. So what will be the answer here? Here the question is how many J omega? How many location on the J omega? How many? Anybody?
The two locations.
Plus
Yeah,
minus 5.
good.
Two location.
Two
Hey,
location.
kill yourself. It's 2. Good. What do you mean by plus minus? Yeah, it is true that this plus minus J5. This how many here? There are 2. 2 pole, 2 close to the pole on the imaginary axis. So this answer will be 2. Now, can you answer how many left hand side then? Here.
Sir, more 2.
Sir, 4.
One person said 2,
Two,
another
the two.
person said 4.
The two.
Sir, 2,
Yeah.
sir. Total 5, sir.
Right. So if you write 4, then it will be total what? 7. So it will be 5. So 5 means what about out of 4, 2 is on the imaginary. So another 2 should be on the left hand side. Why you say 4? Okay. Now you're clear among the 5, 1 is on the right half S plane, 2 is on the imaginary axis, and rest 2 automatically on the left half S plane. Clear?
Yes, sir.
This is how we can say the. Now, can you tell me system is what? Stable or unstable?
Sir, unstable.
Sir, unstable.
Unstable. Video lecture said if there is a single pole on the right half S plane, system will be unstable. So there is one pole on the right half S plane, make the system unstable. For the system to be stable, this should be 0, but it is not 0. So the answer is unstable, and the one pole on the right half, 2 pole on the left half, and 2 pole on the imaginary axis. This is the answer to this question. Clear?
Yes, sir.
Yes, sir.
Good. Now, if you clear, let us go and solve a problem. And you should try to do it a bit faster. Don't waste time, and get your calculator, everything ready. I'll close the door after some time so that the dark, those who leave the classroom cannot enter, remember. And those who did not join the class today, just tell them if the attendance is less than 70%, they cannot attend midterm and drop the course. This is not fun actually. I'm trying to conduct the class, but you are sleeping at home and making it easy so that easily you can join at night. Please let your friends know and immediately join. Okay, now can you see the screen?
Yes, sir.
Oh my God. Just 1 minute, please. Um, just 1 second. Hello, can you hear me? Okay, I hope by this time, maybe your friends and other people. Now let's come back to the point. And as example, as okay, I can pick an example too. Can you just copy this question? For example, if I can say that QS, same question, you have to solve the problem yourself. Let's see whether you can do it or not. Let's say this is S to the power, if I give you S to the 6, that means you understand how many close to pole altogether. Hmm. Okay, let's say this is the characteristic equation. So what you have to do is you have to find the same thing. First question is the right hand side, how many poles, left hand side, and imaginary axis, how many, and hence stability. Stability equal to what? Stable or unstable? So find these answers. Let's say stability is coming if there is, you know that. So can you please do it by yourself first and let's see how you do. So how you start, you know that from the video lecture that you have to develop the Ruthian array. So Ruthian array, how you develop the Ruthian array, you already know that. S to the power what should be the starting point? Can you?
6, sir.
Good. S to the power 6. Now you can just go S to the power 4, 3, 2, 1, and S to the power 0. Now, what is the first row? Anyone can tell me? First row will be what? 1,
Sir, 1, 8,
1, 8,
20,
2016.
16.
2016. Good. And the next one?
2, 12,
2,
12, 0.
12. Good. 2, 12, 20. 2, 12, then?
12, 0.
No.
Oh, sorry.
Anyone
16,
else? Yeah,
16,
2, 12,
16, 0.
16, 0.
Yes.
Because this 2, then this 12, and then 16. That's the others are all the first row, and this is the rest of the thing coming the second row. That's what explained in the video lecture, so everybody understands. Now you please do this calculation faster and tell me the answer. Who had done it correctly, he will get a plus point. I'll take the attendance at the end. Nobody done it yet?
Sir, 2, 12,
Okay, good. The first
12,
row,
16.
first row is what?
2, 12, 16.
The first one is 2.
Yes, sir.
2, no, 2, 12, 60 is this one. What do you mean by that? I'm talking about
The
the
next
third
line
one.
also 2,
Sir,
12, 16.
8, 20,
Oh,
16.
I'm sorry. It is the same
Yes,
thing.
sir.
Okay, good, good. Okay,
12.
16. If it is then what will be this?
Sir, 0, 0, 0.
0, 0, 0. Good. I think then it's all right. Now, then what happened? This is the 0 row. You are getting 0 row here, right? When you get 0 row, then what to do? You have to go for auxiliary equation. And auxiliary equation should come from the above row. So above row is this one. So you go for auxiliary equation. Auxiliary equation will be what? Hey, can you
Sir,
auxiliary?
Sir,
D by dx,
No,
2s.
auxiliary equation. That is the derivation. But equation is
2
what?
s to the power 2, sir.
Right. 2s to the power
2.
2, 4,
12 s to the
4
power
9x
12.
square.
Good. 6 square plus 16 equal to 0. Because this is s to the 4. This is s square. This is s to the 0. So it is coming like this. And what is coming here is now you can tell me, as you said that, sir, it is, you have to do what? You have to take the derivative, first derivative of DDS of these things. And if you take the derivative, what is the thing coming? Hey, what happened? Nobody
Sir,
know how to
8,
do the
8, 8s cube
8s
plus
cube.
24s.
Right, 24s. Full stop. So this is what the thing, as a s cube coefficient 8, s to the 1 coefficient 24. That gives you this value as 8, and this is giving you 24. Now you do the rest of the calculation to find stability. So if you do it now, can you tell me what's the answer you get? Very straightforward. This into
First
this
one
minus
is
this.
6, sir.
Last one is what?
First one is 6.
6. Then second one?
I guess 16.
16, good. It should be 16. Okay, then what is the s to the 1 next one? If you multiply and then find. It's a 8 into 12 minus 24 into 2 divided by 8, right? 2.67. And this one? Hmm? Why not sure? Because this is 0 and this is 0. 0 into 0. You didn't see this. What is this here? It's a 0 here. So
Yes,
6
sir,
into 0. What is that? 0, nothing.
0.
Then what is this?
Yes.
Right, this one 16. So system, how many times sign changes? Hey, how
Sir,
many times
0
sign
times.
changes?
0 times.
0 times
0,
changes. System
0 times
stable.
changes. Then how many, what will be the answer? Right hand side. How many pole on the right hand side?
0.
Sir, 0 pole.
0.
0.
Stable.
System is what?
Stable, sir.
Stable.
Right, system is stable. That's it. Now, the other part, left hand side, there's 0. So out of 6, no pole on the right half. All are on the left half or imaginary. Definitely there is on the imaginary. Because why? Because of there is a 0 row present. That means there is something in the imaginary axis and there is rest of the pole will be on the left half. The left half will be calculated. Left half will be determined at the end. I mean rest. So it will be, now you have to go for imaginary. How many on the imaginary? The same way, auxiliary equation. The auxiliary equation, go for auxiliary equation. Auxiliary equation says what? Hey, can anybody tell me what is that? What what is the auxiliary equation we have written first? Oh my God, you people are.
Sir, 2 s to the power 4 plus.
So please tell
4
me
plus
first. Oh, you are calculating yourself. Good. 12s square plus 6. This is what you need to understand first. 16, right? Then you can just divide by 2. Then you can make it easy, right? S square plus 8. That's it. Divide by 2. Now you assume, let this formula, you can put that s square equal to x. And then you get it here, x square plus 6x plus 8 equal to 0. Can you, now I hope that you have some of you have already calculated. What is X?
Then -4 -2.
Minus?
4 -2.
Minus 4 minus 2. Okay, that means your S square is minus 4, S equal to what? And another one is S square equal to minus 2, S equal to what? Can you?
Sir, plus minus J2.
Plus minus J2. Excellent. And then this one is?
Sir, plus minus root over 2.
Right. Plus minus root over
J,
2.
J root over 2.
Right. So, how many on the imaginary axis? How many pole?
Sir, 4 poles.
Beauty. There are 2 here, another 2 here. 2, 2, 4. So you should write 4j omega over here on the imaginary axis. What will be the answer here?
0.
You get a
Sir,
big
2.
0.
The 2.
2.
2, because there are altogether 6 pole, right?
Yes, sir.
So 0 on the right and 4 on the imaginary. So rest of the pole will be on the so much, so beautiful brain, right? Back to kindergarten school people can easily answer to this question. All right, now let's come here. This is 2. So what happened? You can see after that answer, you have to add them together. If you add them together, it must be equal to 6, right? Isn't it?
Yes, sir. Total 4.
Right. Total 6. And this is the way to answer to the question. Hey, are you okay?
Yes, sir.
Yes,
If
sir.
okay, I'm finishing this by giving another one, and let's see whether you can do it or not. Okay. Can you? You don't want
sir,
to
we
take the
can.
challenge. This time I'm not going to help you. You have to help yourself and try that you can do it or not. Okay. Example 2. And then we'll jump to the next topic. That is the controller gain determination. And that's it. Now QS equal to the s to the power s cube plus 7, sorry, s to the power 5 plus 7 s to the power 4 plus 6 s cube plus 42 s square plus 8s plus 56 equal to 0. Is okay. Hey, got it?
Yes, sir.
Okay, now what you have to do the same thing. Right hand side, you have to find left hand side, you have to find g omega and stability. So I think you can do it by yourself, very simple and easy. Have you copied, all of you?
Yes, sir.
Yes.
All right, I'm
Yes,
going to close it because why? I think it is very simple problem. You can try, you can easily do it. Now let us jump to the Istiak, what are you doing? Okay,
Yes,
now
sir, I'm
listen.
present.
Well, you're present. Okay. With the guitar, you are busy, or you are busy with the class. Okay. Now look, what I'm going to show you now. I'm going to show you the video lecture of the next topic of Ruthian array. That is the next part of the Ruthian stability criterion. Which will give you the impression of determination of the controller gain K for which can affect the stability. Controller gain, proportional controller gain actually K will That stability analysis by the RSC, or Ruth stability criterion, is going to be discussed now. Now I'm going to run the video. You very attentively listen to it. After a certain time, I'll jump to the problem to solve. Here you will see actually how one or two problems to solve, and then I'll show the problem. But all of you need to understand this thing, otherwise you cannot understand the solution to the problem. So all of you please concentrate. Can you hear the sound? Hey, can you hear the sound? No, not my sound, video sound.
No, sir.
Okay. Just 1 minute.
And bring the graph paper hard copy before the next class. Okay, today we don't need it. Next class onward, we need it. So the impact of controller gain on stability analysis, if you mean, it means that if you go to our canonical
Live class people, can you hear the sound now? Okay.
form, like this got, and let us example here that we can take a controller box where the controller gain K is sitting here, and we can have the system here. For example, a system, we can, a plant transfer function we can consider here, and a feedback loop, which can be a unit feedback. For simplicity, we can consider like this. So if you say this is R and this is your final output C, then what will happen? The plant transfer function we can consider here as 1 divided by, let's say, we can just check about it, your S into just any plant you can get, S into S plus 1, S plus 2, just arbitrarily you can write it S plus 1, S plus S plus 2, okay. So S plus 1, S plus 2, like that way a plant, I can arbitrary plant we can consider, and this is the problem if we consider. And then what is this K? K is the controller gain, which can control the system stability here. So how, using Ruthian array, how can we apply it? How can Ruthian array stability criterion can be applied to find the controller gain range or parameter for the system to get the system stable, unstable, something like that. So the question is here, you have to find, for example, you have to find the range of K. This is what the impact. Find the range of K for the system. The K is the gain of the system, as you know. Find the K, range of K for the system. Okay, to be, number one, you can say to be stable. Number two, you can say unstable. And number three, you can say marginally unstable, or we can also say that or critically stable. We can say critically stable or marginally unstable. Both are same, either marginally unstable or critically stable. We can say like that. So this is the problem we are going to solve. If you want to find the solution, then one thing you can see, the whole thing here together, we can say this is your G. And hey, can you tell me what is H equal to?
1.
Yeah,
One, sir.
yeah, it is a unity feedback, so it is 1. So our closed loop transfer, the closed loop transfer gives you the characteristic equation, and the characteristic equation is what? I'm talking about the solution part. So the solution is here, the characteristic equation. Oh, your question is what? Question is here, find these things using, first question, before that you have to write, using RSC. Using RSC, find this thing. So that means using Ruthian stability criterion, you have to find the range of K for the system to be stable, unstable, and marginally unstable. So the characteristic equation is going to be the characteristic, I'm sorry, characteristic equation. The characteristic equation is what? We all know that the characteristic equation is 1 plus GS equal to 0. So if 1 plus GS is 0, then you can write the equation as G is what? G is K over S into S plus 1, S plus 1, S plus 2, S plus 2, and H is 1, so equal to 0. And
Sorry, live class people, if anywhere any question, you please raise your hand or just tell me, sir, I'm from live class, I have a question. I'll stop it and explain.
what is the characteristic equation you're getting here? Ultimately, S cube plus what? 3s square, right, plus 2s and plus k equal to 0. So this is what ultimately you are getting the characteristic equation. Now, if you apply the Ruthian stability criterion, so first job is to find the Ruthian array. If you find the Ruthian array from the last class, I think everybody should know how to find the Ruthian array. Can you tell me what should be the S power start from?
S cube.
Good. S cube, S square, S to the power 1, S to the power 0. And what will the first row?
1, 2,
1, 2. And the second row?
3K.
3K. Good. So if you can write it, then you can easily find the third row. Third row will be what? Anyone?
6 minus K.
6 minus K.
Right.
Right? Good. And then this is 0. And then what is the next one? Fourth row. Final, last row. What will be the last row? Anybody can tell me.
K into 6 minus K.
Okay, live class people, what is your answer? What do you think? The fourth row will be what? Live class, anybody?
Sir, K into
Still,
6 minus K.
what? 6 minus K by 3 into K, and this is 0, right? 0 into 3 cancel out and divided by this. Then what is the thing coming? Normally,
K.
this K should come
K,
here,
K.
actually, nothing else. Okay.
In 6K divided. It is the K answer. So it's straightforward. Not this one. This is not correct. So it is the K answer. So not the other things. But one thing I tell you, you remember that when up to this you come, 6 minus K, 3,000 times. We have solved this problem a lot in the last class. I don't know how come you make a mistake here. Or I am thinking you are watching movie, not looking at me, what I'm showing you movie, most probably. Okay, when it is something like this, you can see automatically then this element straight away will be coming here. Normally, this is the way you can check. Okay, so Okay, now this is the Ruthian array we calculated or we found. Now, if we write that number A, number 1, for the system to be stable, so question 1 said, find the value of K so that the system is stable. For the system to be stable, for the system to be stable, for the system to be stable, what is the condition? In the first column, the number of sign changes will be equal to what?
0.
It will be 0. If I say no sign changes, then what will happen? Then the first one will be, if what is this? This is positive, right?
Yes, sir.
Then the other two, this one and this one, you don't know about them. Now, if I say no time sign changes, that means sign changes is 0. If we want no sign changes, then this one and this one, what will be their value supposed to be? Positive.
Positive.
Positive means less than 0, right?
No, sir.
Then what?
Greater than 0.
Greater than 0. Any children didn't born yet, if you bring him or her and ask this question, he will tell you the same answer, that it will be greater than 0. So there is no credit. Now look at it. This is plus, this is plus. Then if this need to be plus, then that means it needs to be greater than 0. So for the system to be stable, all the elements should be more than 0. The first one and second one is already more than 0. So other one will be also more than 0. So then there will be no sign changes. If no sign changes, all are positive means no sign changes. No sign changes means no closed loop pole on the right of his plane means system is stable. So stability condition is this two. So from these two condition, we can say first one is K is more than 0 is one condition we are getting. The K value is greater than 0. Another condition is coming from here, which is 6 minus K divided by 3 is more than 0. So K will be what? Can you tell me? Okay, I'm just writing it a little bit details. That means 6, I think all of you can understand this. 6 of K is greater than 0. This thing you understand, right?
Yes, sir.
Okay.
K is greater than 6. That's why
Less than 6.
yeah, that's why I'm doing it, because you will answer that thing. Okay, so one condition we get K is more than 0. Another condition we get K is less than 6. These are the two conditions we are getting for the K for the system to be stable. What does it mean? This thing means what? This means if you look at this graph, I'm showing it here, you like these things and you can just consider the graph that K equal to 0 here and this is equal to 6. That means what? K is greater than 0. K is greater than 0. Another one is what? K is less than 6. Right? This is what? K is greater than 0 and this is K is less than 6. This is the two limit. Means within this limit, within this region, system will be what? System will be stable. Within this limit, K will be stable. In bit, that is K is more than 0, K is less than 6. So his system is stable. So what can you write here in this general way? K is less than 6 and more than 0. So this is the range we can say for the system to be stable. What is the answer? Answer is K is less than 6 and more than 0. This is the answer to the question number 1. Find the range of k for the system to be stable. So this is the range for the system to be stable. What the next question is, what is the unstable range? Unstable range will be outside this range. So if you go outside this range, that is your unstable. So your question number 2 is unstable range is k is unstable range is k is more than 6. If k is more than 6, system will be unstable. Okay. And number 3 is marginally unstable or critically stable case. That will be in between these two. That is a point where is k is less than 6 and k is more than 6. But there is another point which is what? K is equal to 6, right? That is only one critical condition, and that's why it is called critically stable. Critically stable, because this is the critical value of k for which system is neither stable nor unstable, which is like a marginally unstable case of critically stable. That means the closed loop poles located on the imaginary axis. Imaginary axis means, you remember, it is sine wave. The response will be like oscillation. It is neither stable or unstable. If it is stable, then oscillation will be going down slowly. That is stable. And if it is unstable, k is more than 6, then it will be like this. Become bigger, unstable. So this is less than k is less than 6. This will be k equal to 0, k equal to 6, and this will be k is more than 6. So that these 3 responses you can get for which the system will become stable, unstable, and marginally unstable. Hey, you understand it?
Yes, sir.
Let's go back to the lab class. You have any questions so far, or you have question? Otherwise, we're going to solve the problem. Anybody got any questions so far? Are you all sleeping?
No,
Hey,
sir.
can you listen?
No, sir.
Okay.
Yes.
Yes, sir.
No responses, dead or busy with something else. I don't know. Okay, now let's come back to the body. If you have no question, everybody clear, right?
Yes, sir.
Beautiful. Now let's go to the dashboard and let's see how we can, the whiteboard, then we can see how to get it. Can you see? Are you not responding means?
Sir, it's still loading, sir.
Oh, okay. Now it's okay.
Yes, sir. That's it.
Yes,
Okay,
sir.
good. Now there's a question here that if this is the characteristic equation means 1 plus g, as you know that. I think you are, you know that hey, can you see I'm writing?
Yes, sir.
Okay, good. 1 plus gh, like this thing, right? And I said this is equal to 0. This is a characteristic equation. This characteristic equation is this lower part actually. This equal to 0 is a characteristic equation. I told you several times, and then the servo system I have also told. This is a characteristic equation. Sometimes you get this QS is this 1 plus GS. Now your G and H, if you put G and H, let's say here in the canonical form, I think you already know that I'm showing. Just still, I'm just going to show H, and this is C and R, whatever. Here you got 5 by S into S plus 1, S plus 2, whatever, and H equal to 2 by S. And then G and H, you substitute, you get some polynomial form. Let's give it S cube plus 3S squared. Like if you substitute, that sort of thing, you are getting it here, just I'm talking about. Okay. So this is a characteristic equation given. And what is the question you have to do? That is a question. The question is your find, as just here you have seen, find the range of k, because here is a k there. Can you see? Again, that people are sleeping.
Yes,
sir. We
sir.
can see.
Find the range of k. As if you are sick, I am okay. Find the range of k so that the system is number 1 stable, and number 2 is unstable. Some people are playing game, right? Coming and going, coming and going. Okay, and marginally unstable or critically stable. I think these are the three things you have to find as you saw in the video lecture. So the range of K you have to find for this particular problem. Now we have to solve the problem, and I think we solve the problem how? Let us say how we can solve the problem. First thing you have to do, you know that the Ruthian array you have to create here, and in the Ruthian array, what is the s to the power starting? Oh, you have to break it first. Now, what is that? Q is equal to what? If you multiply, and then what is this? Can you tell me s to the power what? Polynomial. At least one person in the class should do.
S
All
cube
cannot be
plus
done.
3s
S,
square
s to the power what?
3.
Good. S to the power q plus
3 3s square
11
Can
s square, right? Okay, then what? Twenty 21s, then what? All of you, are you all dead body or what?
2s
Yes.
22s plus K.
Right. And someone said 21s, fine. And after that, what? Why you stop? After
Sir,
that,
another
plus
thing
s plus k.
plus
And then 21 and plus 21s and another s. It will be 22s.
22s.
I think I know you know that, but some of the guards are here in the class. They will not understand. They will say 22 where it comes from, and short circuited. They are thinking by this time problem solved and go back. Why 10 is a square? Hey, you are making another trouble in the class, right? These are all troublemaker people. Cannot understand anything, you're just making trouble to the others. Okay, now listen. This is the one. Then what will be the first what will be the s to the power what?
S to the power 3.
Right. Then s square, s to the power 1 and 0. Now let's come back here. What is the first column? First row. I have
Sir, 122,
122.
122. Then
11 and K.
11 and k. Then go for it. What will be this?
So 242 minus K divided by 11.
242 minus k divided by 11. Okay. 242. And then this will be 0.
K, this will be K.
This
This
will
is
be
K.
k. So then can you find it now? The
Yes,
range of k, all these things, what I told. Just do it.
So K is
Hmm.
so K is greater than 0,
Mm-hmm.
then 242.
Less than 242. Okay. This is more than 0 and this is more than 0. So you are going to get k is more than 0, and then another one is 242 minus k is more than 0. Yes, so 242, 242, this k is less than 242, right? So your stable is what? 0 to 242. Yeah, it's less than this and more than 0. It is stable. Here is the stable range, and this is above this is unstable. And in the middle here, this is the, what is that? This is a 242, is the
critical.
critically stable case. Okay. This is a critical. So you can just write it down. This K is here 242 less than more than 0. Unstable case K is more, 242, and this is K equal to 242 is that's the answer. And then this graph, this you done the job. Very simple problem. You can easily solve here. Right. Now, if I ask you to solve a problem here that what you have seen, can you, you cannot see the video, just it's going to share the video. Can see the video. You'll see the video now.
Yes, sir, we can see.
Yeah, now this is what you have to solve the problem by yourself, and just let me know how to do it. Hey, what happened? Just press the button, then button up. Just a minute. Yeah. Now this is the question. Can you? Why it is not going? Can you see?
Yes, sir.
Okay. Can you just try? Why it is stopped here? Can you get a screenshot, all of you? It's possible for. Oh, this is in this way. Oh no, you should see this thing. I made this mistake. Okay, can go for it faster. Can try to solve this problem by yourself. This is cancelled. Let me select the board. Sorry, who is that? Enamul Karim, right? Okay. Go ahead. What is the answer? Mm-hmm. Hmm. Hmm. Okay, I'm talking about the K stable what range? Three by four. Okay. Anyone else got the same answer? Okay. Okay. No
Okay.
problem. Listen.
Sir, K
Yeah.
should be greater than 0 and
Okay. We are going to see this what she answered.
For stability.
yes, sir,
Okay.
for stability.
K is less than 1.5 and greater than 0, like this.
Now, what you said is their live class. Enamul Karim, what is your answer? K is 3 by 4 is 1.5. No. 3 by 2. You are saying what? 3 by 2. Anybody got 1.5? No. Okay, let's see what happened. Now look at it. Is it the thing you got, Enamul Karim? The characteristic
Sir,
equation?
I got the same answer.
Right. Now you come up. What is the answer? K equal to what? Oh, 1.5, right?
Yes, sir, 1.5. Yeah.
Good.
I just did it right now, so sorry, sir.
All right, no problem. I believe it, but you did not tell
Uh,
early.
Sir,
Hey, listen. After after the game is over,
Yeah, yes, sir, yes, sir.
cricket
Understood.
game between Bangladesh and India won. I am in India. Like that sort of answer you are giving. After showing you the answer, you said I got it.
No, sir, I just want to
I
say,
know
yeah,
you can
I
show
got the
me,
one.
but why didn't you
Yeah,
tell me
it's.
earlier? I told you you did it. You should tell me your answer.
No, sir, I did calculate later, so sorry,
No,
sir.
no, no. Okay, now listen. This is the way actually you have to find, and the answer is coming here. K is less than 6. I'm sorry, 1.5 equal to 1.5, more than 1.5. That's the way you have to find the solution. So K equal to, this is the way. Hopefully you understand this particular question. I'm going to finish with this question and then go back. Okay. Someone annotated. Hey, who did it? There's a problem with this. Okay. Um, Now listen, I'm just telling here, can you please try to do this problem faster? The last problem. Go. Okay. This is the problem.
Sir, yes, sir. I've done it. Sir,
What is the answer? Who is that?
Sir, Samuel Islam.
Samuel, what is the answer? Tell me first.
Thus, K is greater than 0 and K is less than 5.25.
Mhm. K is no marginal as well case
Sir, marginal K, 5 point K equal to 5.25.
5.25. Okay. Anyone else got any other result? Okay. Is it the thing you got?
Yes, sir. Yes, sir.
Okay. Then you understand more than 0 and you can get it something like this from there. 7.5, right? So he's wrong. So you got the same thing, right? But you didn't tell me. That's why you should tell me to sure. Now the Samuel Islam, he told actually he took the risk. It's not negative marks here. Rather, if you can lucky, you can get a positive mark. So you should tell. That means you are talking like that. So after winning the game, then you say I am with this goal with this group, right? Now this is the way you have to find. But this time you can understand K is more than 7.5. The stable region is not in between 0 and 7.5. Rather, it is unstable region. Stable region is more than 7.5. It is a little bit different way, remember, because of the negative pole is there. Anyway, so the answer is this. You should understand and note it down. That's the way you have to find it. Now, my question to you all. Hey, come on. Can you remember? Can you
Yes, sir.
listen to me? What I'm just going to give you a negative marks. The reason is why you have misguided the whole class. Can you see the screen? All of you can see
No,
this.
sir. Black skin.
Oh, it's coming just a minute. Is it okay? Hey, it's
Yes,
okay.
sir. Yes,
You
sir.
see. Okay. Who answered this question? All these calculations? Samuel Islam, is it? Istiak.
Sir, I think there will be 10 S's per, I guess.
I will give you negative marks. You told, but anyway. Okay, so all of you correct it, not 11S, because it is what I see. Yeah, 7 and this is 3, 7 and 3 is 10, not 11. Now, answer will be what I understand, but I'm just talking about this is a mistake. Everybody understand, right? This
Yes, sir.
multiplication, you cannot make mistake. That's what I'm talking. You have to back to Kindi. Otherwise, okay. So that's all for today. I think you can I think you completed the Ruthian array chapter. Next, after midterm, we are going to jump to the next topic in our study. It is, well, I'll let you know about it, not now, but up to this, actually, before the midterm, we have completed our syllabus. So, hope should be fine. I'm not going through the RSC again after the midterm exam. So it is closed here. Any question, anything? You can ask me. If you have no question, you can leave the room. But before that,
Sir.
I'm just hey, come on. Yeah, I'm going to take the attendance first. Yeah, thank you very much. Just after attendance, then you can leave the room. And confirmation. After how come 17 people? Some people came late, right? Okay, just hold on. And after I show you the name list, then you then you leave. Okay, just a minute. Yeah. 1 second, because it will be a big problem if it is missed again. 1 and this is 2. Okay, so this is